Hello everyone, my name is Smriti Bhatia Malhotra. Welcome to my Phenomenal Channel. Today's topic is correlation. Correlation, like the name suggests, is basically the relationship between two things. Okay, it's how two things are related. That correlation tells us. So, by definition, the correlation coefficient is a measure of how closely related two data series are. The correlation coefficient measures the extent and the direction of the linear association between two variables. Now, what do we mean by linear association? By linear association, we mean that x and y variables are associated such that y is equal to mx plus b, where m is the slope and b is the y-intercept. The correlation coefficient can take values from -1 to +1. If the correlation coefficient is greater than 0, it means there is a positive linear relationship between the two variables such that when one variable increases, the other also increases. If the correlation coefficient is less than 0, it means that there is a negative linear relationship between the two variables such that if one variable increases, the other variable decreases. The image you see on screen shows the linear relationship among various variables, where the x-axis is the x variable and the y-axis is the y variable for each of these scatter plots. Now, in the first one, we can see that there is a upward sloping line which shows that there is a strong positive correlation between the two variables x and y, because here the slope m is positive. In the next one, we see that there is a positive correlation, but since the dots are a bit scattered here, we say that this is a weak positive correlation. In the next one, there is a downward sloping line, so it shows a strong negative correlation because the m, that is the slope here, is negative. Next we move on to the weak negative correlation where the dots are a bit scattered, but still it is downward sloping, so it is a negative correlation. This is moderately negative, and since in this specific one, we see that there is no correlation because the dots are very much scattered and we cannot form any linear line as such. So here the correlation coefficient is said to be 0 since no correlation. Next we move on to calculation of coefficient of correlation. For this, the first input is another measure of linear association, that is the covariance. If you want to get coefficient of correlation for a study in a forward-looking sense, we use the population covariance. But if we want to study historical data or we want to conduct a sample study, we use sample covariance. So mostly sample covariance is used. So in today's example, I will be proceeding with sample covariance. Covariance of x and y is equal to sigma I is equal to 1 to n xi minus x bar, where x bar is the mean of x variable, yi minus y bar, where y bar is the mean of the y variable, whole divided by n minus 1, where n is the sample size. Sample covariance is the average value of the product of deviations of observations on two random variables from their sample means. The next input is the sample standard deviation of the two variables. So what we do here is that we calculate the variance and then from that we find out the standard deviation. Variance of a random variable is simply the covariance of the random variable with itself, denoted by s square x and s square y. So variance of x is basically sigma I is equal to 1 to n xi minus x bar square upon n minus 1. Similarly, standard deviation of variance of y is sigma I is equal to 1 to n yi minus y bar square upon n minus 1. So the sample standard deviation of x and y, denoted by Sx for standard deviation of x, is equal to root of variance of x. Similarly, standard deviation of y is equal to root of variance of y. The sample correlation coefficient is denoted by small r, which is equal to covariance of x and y upon standard deviation of x into standard deviation of y. Writing the formulas for each, we get covariance is equal to sigma I is equal to 1 to n to xi minus x bar to yi minus y bar upon n minus 1 whole upon standard deviation of x is xi minus sigma I is equal to 1 to n xi minus x bar square upon n minus 1, and standard deviation of y is sigma I is equal to 1 to n yi minus y bar upon n minus 1. So writing it again, we get sigma I is equal to 1 to n xi minus x bar into yi minus y bar upon n minus 1 whole upon whole bracket sigma I is equal to 1 to n xi minus x bar square into sigma I is equal to 1 to n yi minus y bar whole square whole bracket upon n minus 1. So we cancel the n minus 1 by n minus 1, and the final formula we get is sigma I is equal to 1 to n xi minus x bar into yi minus y bar whole upon sigma I is equal to 1 to n xi minus x bar whole square sigma I is equal to 1 to n yi minus y bar whole square. This is how we get the coefficient of correlation. For an explained example on correlation coefficient, check out my next video, guys. Thank you all. I hope you liked the video. Please give your feedback and any suggestions on the future video in the comment section below. Also, don't forget to like, share and subscribe.